Okay, number 5. Now, when you look at this head on, at least the first 3 parts are actually quite straightforward. When you look at the equation, you'll notice that it's actually an expanded form of the original circle equation. And if you're not familiar with the circle equation, it looks a bit like this. It's always x minus a all squared plus y minus b all squared equals the radius squared. And you got to note that a and b are actually the center of the circle. It's the coordinates for the center of the circle. So these are fixed values, yeah? That's one thing to know, they're fixed values. Now, looking back over here, you'll notice that this is, because this is an expanded form, the only way to get this into the standard circle equation form is to always complete the square. You just have to do the reverse. So before you even answer A and B, it's best that you reverse the order of this using completing the square. So check it out. To get this format, what I did is just put the x's together and the y's together, and I use completing the square. If you're not familiar how to do that, the trick is that you always wrap this in a bracket, take off the square, and then half the coefficient of x. So 2 becomes 1. So a nice x minus 1 all squared, and then you minus it by the value squared, so the 1 squared. Same thing here. You wrap this out, you wrap the y's in a nice bracket, so y plus half of 14, which is 7, all squared, minus the value just halved, the value just obtained squared, so minus 7 squared. Now, the quick tip is that it doesn't matter what the sign here says, because the point is you just want to halve the actual absolute value bit squared, okay? You're not worried about the plus minus. It's always going to be minus that value squared. And that's really it. And when you do that, you'll notice that you got your x minus a and y minus b plot. So putting this together, you got all of this term plus all of this term. And then what I did, I just threw minus 1 squared and minus 7 squared to the right side, and I got plus 50. So just work this out, throw it to the right, and you're done. And therefore, comparing it to the standard format where you got center A, B, so remember they use a minus sign here. So if it's minus A, that means the center is positive A, minus B is positive B. So that means you got center positive 1 and minus 7, okay? Whereas the radius is always square root, because this is r squared and radius is just r. So this is 50 equals r squared, therefore r is root 50 or 5 root 2. The question doesn't specify to simplify this bit, but you can keep either one solution. And by the way, this is for results of A and B, okay? Now, since we've done that, let's jump straight to part C then. So find the y coordinates of the points where the circle C crosses the y-axis. Now this is dead easy. Just think of the y-axis again if you forgot. And if the circle crosses it, let's say it crosses it like this for some reason, yeah? This means that at some point when it crossed it here, the x value was stuck at 0. So we know that the x coordinate is going to be 0 for both, okay? Anytime you cross the y-axis, x is 0. So what I did in part C, I just said crossing the y-axis implied x is 0. Then all you do is just plug in the value x equals 0 into the circle equation. So replace x with 0 to this, or even this one here. Both is fine. Actually, this would have been better. Solving it, and you should get, you know, just do your standard maths. Solving it, I used the circle equation formula. Square root this value. Minus 7, you should get either minus y equals minus 14 or 0. So the pair coordinates would be 0, negative 14, or 0, 0. Find an equation of the tangent to the circle over here at the point 2, 0. Okay, so to summarize this one nice and easy, because I've already drawn it, just imagine the circle equation, yeah? So let's just draw a nice circle, and let's label the center 1 minus 7, as we found earlier in part A. Now, the tangent line is going to be this red dotted line I drew over here, okay? Now, this red line over here represents the tangent of the equation where it hits exactly at 1 point, i.e. 2, 0. This is just a sketch, so this is not an accurate diagram. It's just an idea. Now, the only way to find the equation of this line from this information is to realize that we can firstly find the equation of the line from the center to 2, 0. And remember, and this is something important, that the tangent is always perpendicular to the radius. So when you find the equation of this line, the gradient of this line is perpendicular to the gradient of this line here. So that makes literally our equation simple. So my tip, find the gradient of line L1, i.e. find the change in y over change in x, which is over here. For example, minus 7 take away 0 over 1 minus 2, and that should give us 7. That's the gradient of L1. That means the gradient of the line we want, L2, is going to be the perpendicular gradient. So take the reciprocal 7, so 7 becomes 1 over 7, and then stick a minus sign, because remember, this is plus, it becomes minus. And there we go. So far, the equation of line 2 is y equals minus 1 over 7x plus c. So we're practically done. Now to find c, well, easy. Just plug in any known point on this line, and that is 2, 0. So we say at 2, 0, so when x is 2, y is 0, plug it in, you get 0 equals minus 2 sevenths plus c. Make c the subject, and you get 2 sevenths. And yeah, that's really it. So you found c, and now, yeah, we're done. So our final equation is y equals minus 1 over 7x plus 2 over 7. And just, make it look nice. I just decided to times 7 to clear the fraction, and then rearrange it so it looks a bit like the form they want, which is what? Ax plus by plus c equals 0. So make everything equal 0, and yeah, we're all done. That's it. So like I said, this question too, I mean, if you understand how to do, if you understand the concept of tangent to a circle, it's always perpendicular to the equation from the radius. So that's my tip advice here. Always find the equation of this line, the gradient of this line, and just use a perpendicular gradient. And it helps if you sketch. If you sketch, it makes the whole problem easy. But anyway, guys, if you enjoyed this question too, give me a like, share, subscribe, the usual things I've been saying. But otherwise, let's move on.